Thank you, and good morning, everyone. This is really exciting, the biggest AusNOG. I'm a little nervous. I haven't spoken in front of a crowd in a couple of years, so let's see how that goes. Today, internet routing, but it's not just BGP. Many of us here are network engineers. We operate networks, and we think that we can control bits by using BGP, but BGP is not the only answer. So, internet routing. When I started learning out, I started learning my CCNA like 25 years ago, something like that. And RIP version 2 was what I was learning. It was a really exciting protocol. It was classless. You can actually put a /24 out of a class B address. That was really exciting. But that's not it. As I started operating a network, we started running a real IGP like OSPF or ISIS. But again, it's not really for what the internet is doing. So obviously it's BGP. Right? You think that has to be the answer. BGP is how we're controlling internet routes. So thinking of how the internet looks, you have a client, you have routers or network devices in between, you're speaking to a server. Between those routers, you have a BGP connection, establishes routes in both directions, and traffic flows. You can make a connection. But there's a really, really critical thing that sits in the side there that is often forgotten about by network engineers. And that's this little thing on the side called names. DNS is sitting there, and DNS is really, really important. And I know Jeff is going to laugh, and he's going to have a really good time at this next slide. When I say, is DNS a routing platform? I was expecting that. You'd be surprised to find out that likely most traffic traversing your network is routed by DNS. And I'm using the term routed because it is absolutely signaled to go in certain directions inside your network through DNS signals, not through traditional routing signals. In some ISP networks I've measured, it's roughly 50% of the traffic on their network. It's not just directed to an IP address, it's actually routed to specific locations inside their network because of what is the DNS answers or adjacent to the network. A lot of other providers, content generators, will use application logic for routing, which is not always visible in DNS. And there are some exceptions. So I operate a very large Anycast network, and we don't use DNS for routing in the same sense as that. I don't want to talk much about this, but if you want to find out more about how Anycast works at scale, please find me. I can talk to it. We have a lot of information online. This is using BGP in the very simplest way. So how does it work? How does it work with DNS routing? There's quite a few different classes of what's happening. You have networks which operate purely at a network level. I call them like Akamai or Fastly, where they're not necessarily controlling the application, but they are doing routing for it. Then you have a mix. You have applications and networks, and Netflix is a great example of that. They operate a very large content delivery network, but they also embed the routing inside their applications. And then you have other applications just standalone like Disney, although they are building out their network as well. Also, we'll talk about today some tools that are used, so IP geolocation feeds. eDNS, client subnet, is a very important tool used by some of the networks to do the mapping, and of course BGP. Having a look at understanding what's happening, because a really important thing of looking at your network and how it works is you need to understand what's happening. Why is this traffic going here? How do I understand what's happening? And the ones that do it at the network layer are pretty easy to reverse engineer. It's pretty easy to understand. First looking at Akamai, so I did some digging into what happened. So I pick an Australian website. I live in the United States, but from my home connection, I look up sbs.com.au. They're using Akamai. From their DNS hosting provider, they send a CNAME towards an Akamai address. So you can see sbs.com.au is CNAME to sbs.com.au.edgekey.net, which is, again, through another CNAME chain. And eventually it gives me an answer of an IP address. And so you think, how did they know to give me that IP address? What relevance is that IP address to me? And so from my home, or I think this is from my corporate connection, we're running through and I do a trace route towards it. It's about 9 milliseconds away, so it's pretty close to me. So it makes sense that they would map that. It looks like it's directly connected to me. I don't see any other ASs in between. So from here, there's Cloudflare and then Akamai. So it's a pretty direct connection. I believe the slides will be online if the text is a bit small as well. So sorry about that. So how did they know to give me that IP? Akamai actually gives you a really cool tool for diagnosing parts of their network. If you do a dig whoami.akamai.net, it'll tell you the IP address of the resolver that went and asked them the question. So if you're using 8.8.8.8, so in this command you could do dig whoami.akamai.net at 8.8.8.8, and it'll reply with a Google IP, because that is what is going and asking Akamai. It's also a really useful tool for finding if your DNS is being intercepted, because if you expect to see a Google IP but someone else is in there, someone's probably picking up your packets in the middle. So they know what that IP address is, so they can see my resolver's IP. Then they actually go and do a geographic lookup of where that IP address lives. So in this case, I'm just using IPinfo as an example. They're a geolocation database. They work very well in a command line. You can just curl against them to find out things. And so doing this curl, looking at that IP address, asking what city it is San Jose. So I live in close to San Jose, so that's a close enough mapping. They gave me an IP address from San Jose. But how do I know that this is the right IP address? So let's test it from far away. Looking at Telstra's traceroute tool, when I traceroute to that website, it's 140, 150 milliseconds away. It's going across the ocean. So it is far away from something in Australia, but it's obviously very close to me. But again, still continuing on the Telstra traceroute website, if I throw in www.sbs.com.au, it maps to a different IP address. So you can see there the 203.46. For me, it was mapping to 23.208 or 203. So different mappings. They're using these DNS resolvers to actually do the mapping. Akamai is not the only network like this, so I picked on Fastly here as well. Again, well, I was looking for an Australian website, but The Guardian was one that I could find that worked. They have an Australian presence, it counts. Again, you see the CNAME mapping there. They're mapping from theguardian.com CNAME to a Fastly map. It gives IP addresses. Pinging them from my home was 7 milliseconds away. When I try and reach them from Australia, this time I was using the connect.com.au looking glass. Different IP address, still very low latency. And the connect.com.au IP address, trying from my home again, is big latency. So different answers. They're actually routing things to where they should go. Some more interesting ones, and it gets really difficult to understand what's happening. One of the things that Cloudflare does is we actually operate a forward proxy service to our customers, so a browsing product. And we actually have content traveling through our network. And so in some cases, we need to understand what's happening to work out. And I spend a lot of time working with this network, in this case here is Netflix, is sometimes they were mapping to weird places around the world, and I wanted to see where they were mapping to and why, so had to dig into it. So Netflix operates their own network, and they have routing built into their application. You can ask DNS, but it's not going to help you. When you look at netflix.com, it just points to an application running on AWS, and that is not where the traffic is actually coming from. They do have some friendly information online, so if you host a OCA appliance, or their website also lists it, they talk about the flows that actually happens to get content into their network, or from their network to the ISP. But this still didn't really explain why I was seeing weird mapping problems, and so I actually started diving into it. Again, since we're talking everything Australia, I watched a great Australian show that I used to watch, Heartbreak High. It's on Netflix. I think there's a new season coming out soon, so it's exciting. I'm looking forward to it. So I started watching this, and data starts happening. The screenshot, unfortunately, blanks out the video, but going into Chrome, I had a look at the network analytics and see what was happening. I could see all of these video files being delivered. I have a look at the headers for them, and if you can see there, it's a little bit small, but the request URL actually shows a very unique address. And so zooming in on it, you can see it's mapping me to a node in San Jose inside Netflix's network. So the application was giving me this answer. This was inside Chrome. I'd opened Netflix, which was running on AWS, but there was a specific video file that it was telling me to fetch from the application. There was nothing from DNS that I could look at. So how do I get there? How do I find this out? One of the interesting things that I found out is fast.com. It's a great tool, great speed test tool, use it all the time. But fast.com actually exposes inside it the mapping that Netflix is doing. So again, we have a look at the network analytics tab inside Chrome, and have a look what's being returned. There's actually a JSON file titled v2 inside of it, which returns all of the CDN nodes that you're being mapped to inside their network. So from here, I'm able to see, hey, look, I'm getting mapped to San Jose or the development environment in San Jose. So that helps me understand what's actually happening inside the application, helps me understand why I'm getting to where I'm going. So fast.com exposes these URLs, and some with reverse engineering, you can run this from the command line. Please don't copy my scripts, they're terrible. But there is, I think there's 6 pipes in there. It got me to where I was going. But I was able to pull a API key, make a request against the endpoint, and it told me how we're mapped. So this is really cool. We actually have something similar to this, although written by someone smarter than me, to monitor how Netflix is mapping certain things around the world to make sure that things are getting mapped properly. But how does Netflix actually get there? How do they actually get that information? So Netflix is using BGP to their embedded OCA appliances, if you host one, from their IX sessions. So if you peer with them at an internet exchange or have a P&I with them, or actually from the transit network. So they actually ingest all of this BGP data, which then gets funneled into their application, and their application tells you how to be mapped. So BGP is being used there, but you may not be able to control it directly by BGP as you normally would. Diving in some more, how do some other applications work? So I looked at Disney. Again, the same thing. In the Network Analytics tab inside Chrome, I'm able to see I'm getting mapped to vod.akc.na.west1.media.disney+. Have a look at that, and hey, look at that. It seems to be Akamai. So inside their application, they're just directing you to a CDN, and the CDN is doing the mapping as you would normally see. There's a lot of important tools. So I grew up as a traditional network engineer, but I needed to understand how everything worked, and a lot of these tools helped me actually get there. And these are becoming more prevalent too. So GeoIP feeds. Out of interest, does anyone operate their own GeoIP feed, the RFC, 8805 format? I can see there's one hand up, which I love seeing. So not many. If you're operating your own public network, you should really do this. Just quickly first on this. So MaxMind is a very common tool to use. So if you want to find out how things are getting mapped, look at MaxMind. They have a free public webpage which looks at it. But it's really important to look at publishing your GeoIP feed. It makes your life easier. It makes the content partners' lives easier. It just makes your browsing experience better. RFC 8805 is published. I think Google was the main driver behind this because they wanted to be able to map inside people's networks better. But publish a feed. For example, Cloudflare publishes its URL there. It's a very long one. We have GeoIP locations of pretty much everywhere on Earth. But in case here, this is an IP that's mapped to Sydney. And so if you're using one of our browsing products, you may get mapped to that IP, which is geolocated to Sydney. And when you open up Google and search, I want to buy pizza, it's going to suggest one in Sydney, which is a good thing. So if you don't already aware, please look at RFC 8805. It is very easy. There's a continuing RFC on that, which is 9092. Which is finding and using geofeed data. And our friend has actually written a script to go and scrape the Whois data. So in 9092, the idea is that you actually publish the location of your feed inside your RIR data. So it's very easy to find out what your addresses are and where they're going. If you're having GeoIP detail problems, there's a very useful resource from wireless ISPs in the United States, the brotherwisp.com. And they give contact details of all the GeoIP providers and how to manage it. Excuse me. Another interesting tool, and I'm sure Jeff has talked about this in depth as well, EDNS client subnet. Some of the resolvers, some of the content providers rely on that data to actually find out where you are. In the earlier example, Akamai was just mapping me based on my resolver's location. So if you operate a network, say, across Australia, but you only have a DNS server in Sydney, all of your users might get mapped to Sydney, and that's not going to be very good. So the idea with EDNS client subnet is the DNS resolver will actually tell the authoritative server the request for this information actually came from this subnet. You can specify a subnet size up to a /24. So it gives better location of using that DNS data for routing the details. It's explained in RFC 7871. Google has some good information around it. I'm not sure how prevalent it actually is, but it is there and available to help with mapping. BGP obviously is a very important tool. I said that BGP isn't being used. Netflix is obviously using BGP. If you're working with a network like Cloudflare, your entire routing experience with us is relying on BGP. So, what's next? I spent a lot of time diagnosing this information and teaching people inside my company this information. We actually have an internal wiki where we explain all of this. But I want to bring it public. I'm thinking if there is interest in this, I'll create a GitHub page. Anyone can submit to it and explain how networks are routing so that we can share this information and help grow as a community. And I did rush a bit, but are there any questions?